Alright, good morning, Financial Lit. I am going to cover some more examples of compound interest to go over it with you, and then some more annual percentage yield examples. So this is the formula that we have learned, We've done simple interest, and we learned the other day in class that we can use simple interest to compute compound interest. It just really gets cumbersome. So if something's compounded, let's say quarterly, we could use simple interest. We would just have to keep using it over and over again. Whereas if we use the compound interest formula, which I kind of showed you that I derived by using the simple interest formula, if we do that, then we can actually get our final balance at the end without having to compute it more than once. It'll tell us, especially if we have things that are compounded quarterly for 5 years, I mean, if we have a problem like that, that would get really cumbersome using the simple interest. So now we can use the compound interest formula, and that's what we're going to use. So here is an example. So we are going to set these things up exactly like we have in the past. We're going to say our principal, so Rico deposits $800 at a 1.87% interest. It's going to be compounded quarterly. I'm going to underline quarterly because that's going to help me determine some of my stuff. What is his ending balance after 1 year? So my principal is 800. My rate as a decimal is 0.0187. My time is still 1 because it says after ending balance after 1 year. But now I have my n, and my n is going to be equal to quarterly. And if we look at our notes that we got from the other day, we would know it's 4. Okay, so we will know we're going to use the same formula. Why isn't this working? Okay, we're going to use that formula, the compound interest formula. We're going to plug it in. We have our 800 where the P is. We have our interest rate right here. We have our quarterly, our N is right here. Our quarterly is here, and our time is here. So we plug all of that in. We end up with getting, we get 815.065. Now remember, we've talked about rounding to the nearest penny. It's going to be very important that we round to the nearest penny so that we actually get a final answer of $815.07. So this class is going to be talking about doing some math, but putting it into context. So we've got to be really careful that we put it into the correct context. So when we're talking about money, we're always going to round to the nearest penny. Okay, so this is example 2, and this is on the notes posted. So we're going to do P, we'll do R, we'll do T, and we'll do N. All right, so our principal, we're going to deposit $1,900 for 1 year at a 2.3%, so 0.023, and it's going to be compounded daily, and again, that means 365. So I'm going to go ahead and plug that into my formula that we've been using, that compound interest. We plug in all the different things. Again, you might want to use Desmos because if you use your TI-84, you have to put it in a certain way for it to compute. All right, again, we get a number. We get 1,944.205. We have to actually round to the nearest penny. So our answer is actually $1,944.21. Okay, so I think this one is put in your notes. If it's not, you can add it. So again, we have our principal, which is $1,200, into account that pays a rate of 0.017. It's going to be compounded monthly, so my N is equal to 12. And what is my ending balance after a year? So my T is 1. Let me see. Okay, so this one is not in the notes. So if you want to get practice putting this all together, we are going to do 1,200 times 1 plus my rate, 0.017, over 12 raised to the 12 times 1. So I'm going to take all of that and I'm going to plug that into Desmos. So let me get to Desmos and I'll do that right now. Okay, so I plugged this into Desmos to get my answer. Again, it looks exactly the same way I would write it in paper. Be careful that right here you hit Shift 6 to get you an exponent. This is an exponential graph, meaning that it's going to start growing like this and then grow quicker. So be careful with that. Make sure that this is an exponent. That was something that I noticed in class. So then our answer ends up being $1,220.56 because this 9 tells us that I need to round the 6 or the 5 up to 6. So our answer was $1,220.56 after 1 year. Let's see if I can get this to work. Come on. There we go. Alright, so this one is the same one we did the day before. We've already done this, but I wanted to go over it one more time, but we're actually going to use these numbers for Kate. So we're going to put in our principal, which is $2,350, and our rate is a 0.011. It's compounded monthly. So our N is equal to 5, but our time is monthly. I'm just skipping ahead. Our monthly, so 12, and our time is actually 5. So we're going to plug all of that in. We have 1 plus 0.011 over 12 times 12 times 5. So there we go. So we're going to plug all of that into Desmos. Go ahead and get practice doing that. If you're using a calculator, make sure that you get practice doing this and get the same answer as me. So again, I plugged everything in. I put in my principal, my rate, my N, my time, and I get that after 5 years, that account will have earned, the account balance will be $2,482.81. So go ahead and put that in your note. So I think I said it was $2,482.81. Make sure that's correct. I'm going off of memory. Okay, so that was our last example for that. So we are going to skip that one. So now you should be able to do worksheet A with no problems. We are going to talk about APR versus APY, and those articles are posted in Google Classroom, so please read those. If you want to go through this, hit pause. This is something I will cover. Okay, so this is the formula. We already have it, but we are going to be talking about it. So we did this example the first class where we practiced doing it, but now I just want to show you again how it works. And so then we get that, and how you get from the decimal to the percent is that you're going to multiply that decimal by 100. So if Barbara deposits a $3,000 in a CD, so we're going to worry about our rate. So the rate is 0.011 because it's 1.1%. It's compounded daily, so our N is 365. What is the APY in the nearest to the nearest 100%? So we are going to figure that out. Again, I need to use Desmos. Okay, so I plugged everything into my formula, my APY formula, and I got this decimal. And I went ahead and counted 1, 2, 3, 4, 5 decimal places to make sure that I get the right number. And we're going to get 1.106%. So actually it's going to be 1.11%. So we're going to round to the nearest hundredth. So let's go ahead and put our answer. So again, we're just going to walk through this. So we have our formula, we plug it all in, and we get 1.11%. So make sure you have all of that in your notes. If you have any questions, please ask. You can email me, you can send it to me directly in Google Classroom, you can ask me in person. Again, my office hours form is set up in Google Classroom, so if you need to schedule a time with me, if you have any questions, feel free to do so. I hope you all have a great day, and I will see you at the end of the week.